Okay, welcome back. So we're going to make a start. There's a couple of people still not here, but we'll just move on. So you now know what a capacitor is. You know the capacitance formulae, both for calculating it if you've already got a capacitor and also calculating it if you know the physical dimensions of a capacitor. And hopefully you've tried some questions to practice those formulae. What we're going to do this morning is actually use a capacitor for one of its most common uses, which is to kind of use it as a clock. So let me just go through the experiment that you're about to do. Yes, I mean it. You are about to do, kind of, and then we'll do it. So on the desk over there, I'll move the camera over a sec so you can see it. I've got this circuit set up, and what I'm going to do is I've got the power pack set to about 6 volts. That's going to be our initial potential difference. That's why I've labeled it with a V0, 0 for time 0. And I'm going to connect it via this switch, which can swing either way, to a capacitor. So it'll start with the switch over there, and that's going to charge the capacitor up to 6 volts. And that means that it's going to deposit a load of electrons onto one of the plates by stripping them off the other plate. So this capacitor is about to become charged, and it will be initially at the same potential difference as the power supply. However, what I will then do is move the switch across and connect this circuit instead, and it'll allow the charge to flow off the negative plate of the capacitor, round the circuit, through the resistor, and back to the positive plate. As it does that, it will discharge the capacitor, and the charge that's on it will start at whatever its initial value is, and it'll come down and down and down and down and down until eventually the charge becomes 0. Now, we're not going to wait for the charge to become 0 because it takes, I don't know, 10, 15, 20 minutes before that happens. So we're just going to do this experiment for 5 minutes, and it will actually discharge most of the way in those 5 minutes. The resistor that I've picked, I'll check when I get over there, but I think it's 22,000 ohms. So it's quite a big resistance, and that's because the capacitor will actually discharge very quickly through a low resistance circuit, and we won't be able to write the results down quickly enough. Our human brains and arms don't work that fast. So I've put a resistor in it to slow the discharge right down. And that gives you a little hint already that I can probably turn this into a clock by varying this resistor to make it discharge at whatever rate that I want it to discharge. So there's loads to learn about the discharge of a capacitor. You might want to be thinking in your head while I move the camera, what kind of shape graph do you think we'll get of the potential difference against time? We could, by the way, have used a different meter. Instead of a voltmeter, we could have an ammeter, and we could watch the current start at a particular value and then get smaller and smaller. Or we could have a coulomb meter, and we could measure how much charge is on the plate directly. But it's, you know full well, it's easiest to do this with a voltmeter. The voltmeter is a direct measurement of the potential difference here. And if we know what the capacitance is, we can use the capacitance formula to turn it into the amount of charge. I've got loads of voltmeters. I don't have very many coulomb meters. So we can use the capacitance formula to get the charge. And as for the current, well, we need to think a little bit about how the current's going to behave. So let's go with what we know. We know that we will charge it up to a particular potential difference, and then that potential difference will go away as the charge dissipates. So let's start with safe ground, and we'll complicate it up in another lesson. Okay, I need you to write down through your screens the value of the potential difference as the time ticks by, and I need you to do it for 5 minutes, up to 300 seconds. Now, you might have an inkling already of what's going to happen, but I'm just going to tell you now that your life will be so much easier when it comes to drawing a graph if at the very least you take measurements every 5 seconds at the start. You'll see for yourself that later on you might want to drop it down to every 10 seconds so that you've got fewer points to plot when you come to plot your graph. But at the beginning, at least, you need to do it every 5 seconds. And then when you've got this huge amount of data, and it is going to be a lot of data points, I need you to turn it into a graph. And what we're going to do is I'm going to move the camera now. It's going to take about 5 minutes to do the practical. And then you're going to get about half an hour to actually draw the graph now. And then we'll reconvene the meet in about half an hour's time, and we'll all have a look at what shape your graph is. Okay, so if you don't have a piece of graph paper, I've posted a PDF of some to Classroom, and you can print that off and just use it like a regular piece of graph paper. If you don't have a printer, you could use Excel or Google Sheets, and you could put the data into that and then just tell it to generate a graph for you. However, if you do use some software to generate the graph, I need you to then play with the style settings so that the graph looks like graph paper and looks like points. So make all your lines thin, put your minor grid lines on, make the crosses appear like proper crosses rather than blobs or anything like that, and then draw the line of best fit yourself by hand, which either means printing it and drawing it on by hand, or using the arc tool in Excel to draw an arc on, but then tweak the points yourself to make it fit the way that you would have drawn it by hand if you're doing it on screen. Okay, let me move the camera. This is being recorded, so later on, if there's anything from the notes that you haven't managed to write down now, you'll be able to just play back the recording and press pause to fill in your notes. But the minimum that you do need while I'm moving the camera is you need yourself a table which has got the numbers 0 down to 300 in it. I would go in steps of 5, and then if you choose not to do the ones ending in 5 after a while, then you'll just have gaps in your table. But you will, if you're taking measurements every 5 seconds, you need this side of the table pre-filled so that you only have to worry about scribbling down one number in your 5 seconds between readings. So you make yourself a table of results. I'm going to move the camera, and then we'll have a look at the equipment. Okay, so let me talk you through the equipment that's on the table in front of me. So here's the power pack, and in the red wires, if I bring this back enough, here's the capacitor. Just follow the red wires with your eyes. So it's coming out the power pack, and it's going into the positive side of the capacitor. Notice the capacitor's got the negative side labeled on it really well. And then it's coming out the negative side of the capacitor through the switch and back to the power pack. So that's the charging side of the capacitor. And in a second, when I throw the switch, you'll see that the voltmeter here jumps straight up to around about 6 volts. Then in the black wires, if you follow the black wires, we've got coming out of the negative side of the power of the capacitor, we're going, here, positive side of the capacitor through the resistor back to the switch, and then we're sharing the red wire back to the capacitor again. So that's the discharging circuit, and the resistor here is set on 22,000 ohms, and that'll just slow down the discharge a little bit for us. In the yellow wires, I've then got the voltmeter attached across the capacitor. Now, I'll charge it up, so I'll just flick that over to positive, and you can see that the voltmeter has come up to about 6 volts or so, 6.07. I'll move the camera in a second so that you can see it properly. Now, when I flick the switch, this is going to start discharging like this. Let me put that on. Okay, so it's going to discharge at this kind of rate. So you're going to see those numbers go down like that. And what you're going to need to do, I'm just going to reset it, is you're going to have to write down that value every 5 seconds, at least initially, until it slows down and doesn't change by much over 5 seconds, in which case you then might want to switch to 10 seconds. Right, you are going to need a clock on your screen that shows seconds. So I'm guessing that you do not have a phone very far away from your hand. So if you could be pulling up the stopwatch on that. I tried showing you a stopwatch on the desk here at school, but the figures are just too small and they're a bit rubbish. Plus, it doesn't actually really matter when you start, and it's much better for you to be in charge of that than me. So I'm going to flick the switch and the number's going to start changing, but you can start whenever you want. So just look at the screen, and whenever you are ready to, you hit start on the stopwatch. And as you hit the start button, you need to write down whatever value your eyes are looking at on the voltmeter. So then your eyes dart to your piece of paper. You scribble down the reading that your eyes have just seen on the voltmeter. And then you get your eyes back to the stopwatch, hopefully inside 5 seconds. And as the time hits the 5-second mark, or maybe 4.9, something like that, you dart your eyes quickly back to the voltmeter again and look at the value. And then you write that down on the piece of paper, again, hopefully inside 5 seconds. And then by the time you get your eyes back to the stopwatch, hopefully it hasn't got to the 10-second mark yet. And you're going to do this for 3 minutes. It is probably a very good idea for you to rearrange your desk so that your hand can reach a piece of paper nice and easily, and that it's not too far from your screen. And I would probably put your stopwatch very close to the screen so that you don't have to dart your eyes very far between voltmeter and stopwatch. I'm just going to give you another 10 seconds or so to sort yourself out. Remember, it doesn't matter what value you start at. But I will say the word go as I throw the switch, just in case you want to start when I start. In which case your zero reading is 6.07. Right. Could you please unmute now if you do not have yourself set up and you need a little bit of extra time? Very good. This is being recorded. So during the half an hour while you're drawing a graph, I will upload the recording. And so if it all goes horribly wrong, you can always watch the recording back, and then at least you can skip through and use the time base on the bottom of the screen for your 5 seconds. Okay, here we go. 300 seconds. Okay. 3, 2, 1, go. Okay, that was actually 5.5 minutes. So even if you didn't start straight away, hopefully you have finished now. Okay, what I need you to do over the next, 24 minutes, 25 minutes, something like that, is to draw yourself a graph. Time on the x-axis in seconds from 0 up to 300. Potential difference on the y-axis from 0 up to, well, it was 6.07 at the start. So if you started bang on that, you need to go up high enough to get 6.07 on. Plot all of the points. Draw yourself in a line of best fit. And then I would like to reconvene this meet, please, at 11:25. So you have got just over 25 minutes to draw that graph. I'm going to stop the recording now, but I'll leave the meet running. The recording will appear on Google Classroom any second now. Okay, so draw a graph, please. Unmute if you get stuck.